Infinity and non-terminal limits. Let's get into this. This is like 8,000 times better than your calc class taught by someone not as smart, but I will teach you things that they won't teach you. First off, big respect to you for clicking on a video that sounds like it's for nerds and not for tuning in to Aiden Ross's new stream, the new anime that just dropped. Any of those things might be more entertaining, but this shows that you're prioritizing your education and your improvement over that fake value that could be provided to you. Those dopamine hits from like those shorts. You're not watching that. You're focusing your attention and action on this high, very possible goal of becoming educated. And my promise is that you will be able to defeat your calculus instructor. Some of you might not even have taken calculus yet, but when you do, you'll vanquish them in mathematical debates and defeat static infinities. Boo, we hate static infinities once and for all. You'll be like, screw you, stop confining infinity to outputs, stop linearizing infinity. And they'll be like, what? And you'll be like, yeah. And they'll be absolutely destroyed with facts and logic. And also you can find vacancies if you're ever a custodian of an infinitely big hotel. Quick introduction. I'm Tommy, and CTMU Singularity is where the power of an individual meets the mindset of absolute truth. I help young guys become so self-actualized that they start figuring out the meaning of the universe. Subscribe right now if you want this sort of stuff in your feed. Learn what school won't teach you. Hilbert's Infinite Hotel. You may have heard this paradox before. It's a paradox by David Hilbert about a hotel with infinitely many rooms, illustrating the counterintuitive property of infinite sets, showing us how hard it is to wrap our minds around the concept of infinity. Imagine you run a hotel with an infinite number of rooms. On a particular day, the hotel is completely booked. There are an infinite number of guests. Every time someone comes in, you just assign them to a new room. So even though the rooms are completely full with an infinite number of guests, you can just move the person staying in room 1 to room 2, room 2 to room 3, 3 to 4, 4 to 5, and so on, until the final guest moves from room infinity to room infinity plus 1. This process can be repeated for a finite number of new guests because infinity plus 1 equals infinity. Infinity plus 10 million also equals infinity, according to standard mathematical theory. But then your system breaks. You can no longer keep adding a finite amount of peoples because an alien delegation shows up with an infinite number of new guests. And you're like, oh, shoot, I'm screwed. But no. Although it would seem that this arithmetical system can no longer work, given that we need to move each guest an infinite amount of rooms, this is not so. To accommodate the infinitely large group of guests, we can simply move each room from room n to room n plus 1. So here we go. Infinitely more guests, no problem. Move all guests from room n to room n plus 1. So 1 to 2, 2 to 4, 4 to 6, 3 to 6, 4 to 8, 5 to 10, and so forth. And then all the odd number guests, every odd number room, it's empty for the infinitely many new guests. According to the standard theory of infinity, again, 2 times infinity is equal to infinity. Therefore, we will have no problem moving people from room 1 to 2, 2 to 4, 3 to 6, and so on, until we move the guy staying at room infinity to a different equivalent room equal to 2 times infinity. So we still have infinitely many rooms, and we filled them all, even though we have twice as many guests. So, and the aliens can stay in all the odd number of rooms which have been vacated. Everyone is happy except the cleaning lady. This is paradoxical in all the right ways, and it shows why mathematicians' way of thinking about infinities as static is flawed. It all starts with the phrase, one night an infinite hotel is full. That's not really possible. In CTMU metamathematics, this is a meaningless statement because infinity is defined as a non-terminal process. To say that it's full means that you've actually terminated that sequence. Therefore, the infinite hotel cannot be full except under a conditional definition as it is filling up continuously at any rate over an unbound period of time. So the hotel can be expanding, and then you can say it's an infinitary process that will continue to grow it over time. But you can't say it's full and it's infinite. That's contradictory. Unless we clarify that infinity is dynamic rather than static, the only thing we're going to have is infinite confusion as we try to figure out this paradox and the generally paradoxical idea of infinity within standard mathematical formalisms. Infinity is unfillable because it is a process. It's not a static object. Therefore, the CTMU undermines one of the core axioms of modern mathematics, which is called the axiom of infinity, which says that there is at least one infinite collection in the world. That doesn't even make sense. A collection cannot be infinite because infinity is a process. This is not inconsistent with mathematics, this idea that we're rejecting the axiom of infinity, but only with the assumptions that most mathematicians make by treating infinity as a static object. As Bertrand Russell says, it cannot be said to be certain that there's, in fact, any infinite collections in the world. The assumption that there is what we call the axiom of infinity. Although various ways suggest themselves by which we might hope to prove this axiom, there's reason to fear that they are all fallacious and that there's no conclusive logical reason for believing it to be true. So it's just as mathematically consistent to say it is true as it isn't. Instead, the CTMU moves infinity to the non-terminal domain of dynamical programming rather than terminal domain of static objects. Therefore, it does not make sense to speak of a hotel with infinitely many rooms because a hotel is an object in the terminal domain T, but only as a recursive infinitary process in the programming non-terminal domain N that is non-terminal, meaning it's never ending. So infinity is simply the process of adding more hotel rooms over an unbound period of time, a limit which the terminal domain can approach but can never reach. So at any point in time, a hotel can only have a finite number of rooms, obviously. So 10,000 is technically closer to infinity than 10, but the value of the difference between infinity and either 10,000 or 10 is unintelligible because one is a process and one is a value. It doesn't make sense to say infinity minus 10 or infinity plus 10. Therefore, an infinite collection, if there even is such a thing, cannot be said to have a number at all. Infinity is not an object or set of objects, it is a dynamism. Therefore, infinity does not fall into Peano's definition of a number because it has no successor and does not share the same property as zero and its successors. To call infinity a number is fallacious in the extreme and in a very real way represents everything wrong with modern mathematics, namely confining these infinitary processes to static outputs, making dynamical processes into their static outputs and treating their properties and relations as such. Infinity is called a reflexive number because it is part of itself. Any value within infinity, including infinity itself as it is usually treated, is contained within an infinite set. When treated as a dynamical process, infinity possesses the unique character of hological self-replication, meaning that it injects itself in its interior as its own syntactic covering, defining its own structure and properties. An example of hological self-replication is a very detailed map that must contain the map itself. So if you have a map of the United States, if it were in high enough resolution, technically that map would have the map on itself if you zoomed in really far. And that means that it is it has this self-explorative feature. It contains the map itself. Russell says the map, if it is correct, must contain a map of the map, which must in turn contain a map of the map of the map, and so on ad infinitum. This means that, like the map, infinity is a non-terminal process that does not have any defined starting point, but can start as any number and then continuously and non-terminally injects itself into its own hological interior, meaning infinity is self-reifying. It is ascribing existence and properties to itself and to all of the numbers in the natural number sequence through that syntactified process that we've talked about in previous presentations of the n+1 series. This explains the seemingly paradoxical fact of why infinity plus 1 equals infinity, because a non-terminal definition of infinity defines infinity as a measure, not a number. If you define infinity as a measure, then infinity means that you start treating you start at the starting line of the race and run forever. And adding 1 to infinity is the equivalent of starting at the 1 meter line and then running forever. Either way, we run the same distance, whether we start at 1 meter or start at the start line. This should suffice to show the increased explanatory power of defining infinity as a process rather than a static object. The process remains the same, has the same number of steps, whether you add by 1, 0, 2, or 10,000. Thus, there's not a problem moving each of the guests in the infinite hotel to double their room number, because this infinity is simply defined as the series 0, 2, 2n, 4n, etc., which has the same number of steps as the series 1, 0, 1, n, 2n, and so forth. It's just literally one behind. So since the relation of n to 2n is 1 to 1, meaning that for every number there is exactly one number has that isomorphism, has that correspondence, so too does infinity and 2 times infinity have the same value. So they're the same, since they're the same number of values, they have the same value. They're both a low cardinality of infinity. Even if you change the interval of the discrete jumps, infinity still has the same process of going through the jumps one at a time without ending. So that's how we define infinity. It's going through discrete values one at a time without end. The length of the jump, whether it's 1,000 or a 10 millionth of a unit, doesn't matter. The unit doesn't matter. Get this through your head, because infinity is the name of a process. It's not a number. It's not a number. So a hotel with infinite capacity is not. Hilbert's paradox is a non sequitur. It is logically meaningless to posit a hotel, an object in the terminal domain with infinite capacity. Infinity can only be realized in the terminal domain as arbitrarily large and increasing in value, in which case there is no paradox at all. The number line is non-terminal, meaning that it does not end. So infinity is not the end of a process, but it is the entire process itself. You can see this in this graphic. Infinity is not the end of the number line, because saying that there's an end of the number line is akin to saying that there is a termination of the sequence. Rather, infinity is the entire process of iterating by n to n plus 1 and so forth, all the way ad infinitum. The number line is non-terminal, meaning that it does not end. Whatever arbitrarily large number that you have, I can always add 1 to that number, and I have a new greater value. This process is how we define infinity in the CTMU. Again, this is a very good graphic. It's like it's the entire number line. It's not just the endpoint. It's not the static output that we confine it to. So it's a process that increases a value without boundary, meaning that as we move forward in an unbound time interval, we move closer to infinity as the infinite progression of the n plus 1 series with an arbitrary discrete interval. It is in this sense that discrete infinities, or as they're paradoxically called in standard mathematics, countable infinities, are all equal to one another. It doesn't matter whether I progress 1, 2, 3, n plus 1, and so on, or 1, 3, 5, n plus 2, 7, 9, and so forth. Either way, there is an infinite number of steps in an infinite series. It is defined by the process, not the value. This class of discrete infinities, whether the steps happen at intervals of 2, 4,000, or 0.1, whether each term is double the previous, or equal to the previous, or half the previous, or the previous raised to the power of 9, it doesn't matter. It's a one-to-one correspondence between all of these sets. They're all part of what's called this. It's the smallest of the infinite cardinal numbers. It's the series of discrete infinities called Aleph Null by George Cantor to distinguish it from larger infinite cardinals. Thus, the name of the smallest of the infinite cardinals is Aleph Null. Bertrand Russell writes, to say that a class has Aleph Null terms is the same thing as to say that it is a member of Aleph Null. It is therefore the same thing as to say that the members of the class can be arranged in a progression. So anything that can be arranged in a progression, meaning it has a series of discrete values, can be defined as infinity Aleph Null. Therefore, discrete infinities are simply defined as non-terminal progressions of terms. Not so scary, eh? Any progression remains an infinite progression, no matter how far apart each value is or what their relationship to each other is, 2n, n over 2, etc. It doesn't matter. Infinity is a process, not a value. The expression infinity minus 1 is equivalent to subtracting a single term from an infinite progression, which remains an infinite progression. Also, infinity plus 1 is an infinite progression. It does not mean that by any means that we can subtract infinity from both sides and say that since infinity plus 1 equals infinity minus 1, that 1 equals negative 1. If infinity were a value, we'd have to say that this is true, and therefore that all integers are equal to one another, and we'd basically be subtracting out addition, subtraction, multiplication, and division, and basically any meaningful operation within mathematics. And this is what we sacrifice by confining infinity to static outputs. Russell says any selection from a progression is a progression if it has no last term, however sparsely it may be distributed. Therefore, all non-terminal progressions equal the term Aleph Null. One might assume that all infinite collections have Aleph Null terms. However, continuous infinities have a greater value than discrete infinities. This means that there are more points on a line segment of any length than there are numbers. In fact, for every n numbers on the discrete number line, there are 2 to the n numbers, 2 to the n values on a continuous number line or line segment. So 2 to the n is always greater than n. So you can see that the number of subclasses of that set, the number of things in a continuous series is always greater than the number of things in a discrete series. And it's by a lot, especially as you approach infinity. It's quite a bit. So the um the number of real numbers is 2 to the Aleph Null, far more than the number of on the number lines. Infinitely more, in fact. If a class has n members, it contains 2 to the n subclasses. The number of subsets of a set with n elements is 2 to the n. For example, a set with one element A has 2 to the 1 subsets, two subsets, it has 2 to the 1 subsets, two subsets, A and null. A set with two elements has 2 to the 2 subsets, which is 4 subsets, A, AB, B, and null. A set with three elements, ABC, has 2 to the 3 subsets, ABC, AB, AC, BC, A, B, C, and null. Basically, it's any possible way that we can group those three elements. The number of groupings that we can make to the number of elements is 2 to the n to n. So that means that just as we can basically group those natural numbers in whichever way we so please with the continuous number series, so too is the number sequence defined in that way. So the pattern continues arbitrarily long, meaning that a set with k elements will meaning that a set with k elements will have 2 to the k subsets. If you'd like to see proof for this, you can look it up, but the basic idea is that for a set with Aleph null elements, there are 2 to the Aleph null subsets. The continuous infinity has every subset of the discrete infinite number line. The number of subclasses is always greater than the number of classes because 2 to the n is always greater than n, as we just saw. So basically, the what we're gonna say is that where infinity is defined as a non-terminal process, we can say therefore a continuous infinity contains every combination of every number, even if we're only talking about a small distance between 2 points. Therefore, 2 to the Aleph Null is greater than Aleph Null, meaning a continuous infinity is greater, so to speak, than a discrete infinity, where infinity is defined as a non-terminal process. Therefore, 2 to the Aleph Null is greater than Aleph Null, meaning a continuous infinity is greater than a discrete infinity by a factor of 2 to the n to n quite a lot. This simply means that the 2 to the n ratio holds at arbitrarily high values as n approaches infinity. Russell says 2 to the Aleph Null is a very important number, namely the number of terms in a series which has continuity. As we assuming space and time to be continuous in this sense, as we commonly do in analytic geometry and kinematics, this will be the number of points in space or of instants in time. It will also be the number of points in any finite portion of space, whether line, area, or volume. After Aleph Null, 2 to the Aleph Null is the most important and interesting of infinite cardinal numbers. In the CTMU, although we do not believe in continuous spacetime, we can assign the value 2 to the Aleph Null to the number of points in a topologically contained infinity, such as the containment of the non-terminal domain within every part and aspect of the universe, unbound telesis, and Aleph Null is a number of parts in a descriptively contained infinity, such as the containment of the terminal domain which within non-terminal meta-reality n, called bound telesis. Therefore, the CTMU defines Aleph Null as an infinitary process in the terminal domain, a continuous non-terminating function, and 2 to the Aleph Null as an infinitary process in the non-terminal domain. Therefore, under the proper interpretation, one could creatively say that 2 to the Aleph Null equals Aleph Null, replacing the intension of reality, reality x, with, reality int rather, for 2 to the Aleph Null, and the extension of reality, reality x, for Aleph Null in the CTMU master equation, reality int operates upon or is equal to reality x, and extract the implications, infinities in infinities in infinities. 2 to the Aleph Null is topologically contained within the number line Aleph Null, forming a syntactic covering, just as Aleph Null is descriptively contained within 2 to the Aleph Null. If a thing loves, it is infinite. The bond of the love of 2 to the Aleph Null and Aleph Null literally overcomes degeneration through self-duality, through basically situating themselves as two conflicting elements. So this is a mystery of the CTMU by which I mean not something secret so much as it is sacred. The 2 to the Aleph null represents the 2 emerging from unitary uniqueness. Think the twin serpents of the yin and yang, or the Spirit of God hovering over the space of or the Spirit of God hovering over the space of the formless and infinite deep. And Aleph Null represents oneness emerging from ontological nothingness, forming syntactic covering over all of reality, expanding one's identity to include the whole of existence. As we've said, systemic self-duality, of which the duality between continuous and discrete infinities is the most clear and apparent and pertinent, is the mathematical description of love. As King Solomon said, "For love is as fierce as death, passion is as mighty as Sheol, as the pit. Its darts are darts of fire, a blazing flame." Song of Songs 8:6. The relationship between to the Aleph Null and Aleph Null is important because it's the basis between the tension of discrete and continuous models, the sources of much confusion in mathematics, philosophy, and physics. The CTMU says that any geometric state or continuous transformation is equivalent to an operation involving the mutual filtration of interacting hological state potentials. It is in this sense that infinity can be said to be self-programming through the tension between its continuous non-terminal and discrete terminal aspects being self-creating, self-explaining, and self-sustaining. The first known thing in the creation is infinity. The infinity is creation. Infinity is a formal definition of non-terminal reality. So again, the first known thing in the creation is infinity. The infinity is creation. Infinity is a formal definition of non-terminal reality, and therefore the creation of the universe can be defined as and described as infinity's desire to become self-aware through being bound in a terminal reality. Clearly, this descent must be for the sake of a subsequent ascent. The self-representation of the divine infinite creates a hologram of the universe through the flowing of creative energy in terminal reality T, which then becomes focused by the intelligence of the infinite mind, creatively evolving towards a stable configuration that perfectly balances potency and actuality, embodying the metamathematical space of a self-actualizing, self-potentializing conspansive manifold, a reality self-simulation in which we are all observers. The number series Aleph Null is the infinite's discernment of finity, the limit of the viewpoint leading to a never-ending exploration of its interior manyness. The infinite is the process of self-discovery. It is the friends we make along the way, so to speak. Through us, infinity invests itself in the self-exploration as cognitively bound observer participants that participate in structure and dynamics, living in the display of the reality self-simulation while being essentially infinitary. We are operators of infinity, descriptors of the unbound. Infinity knows itself through us. 2 to the Aleph Null represents infinite singularity, whereas Aleph Null represents infinite wholeness, the two complementary aspects of God, corresponding to his 2 Hebrew names, Hashem and Elohim. This will be discussed at length in my book, The Pillar of Ground of the Truth. The tension between infinite singularity, the limit of non-terminal meta-reality N, and infinite wholeness, the limit of terminal reality T, causes the self-generation of the universe and all of its properties. Infinite singularity provides syntactic covering to infinite wholeness, distributing over it and descriptively containing it, because the whole is by definition one. This can be seen by the notation for infinity, which Cantor probably chose intentionally. Aleph Null means Aleph, which has a numerical value of 1 in Hebrew, and 0, the null. 0 is the algebraic representation of nothingness, or more accurately, an ontological formulation of nothingness corresponding to unbound potential. 1 is the algebraic representation of the system, the ontological formulation of its identity. So you can think of Aleph Null as an on-off switch for reality, corresponding to the ones and zeros of binary two-valued logic, an informational system, and 2 to the Aleph Null corresponding to an infinite valued logic of a cognitive self-transducing non-terminal cognitive operator on that information, giving rise to a self-synthesizing informational system that reflects the intrinsic self-duality between cognition and information at the infinitary limit. So Aleph Null is the primary syntactor, 2 to the Aleph Null is the primary teller. So here you can see the primary syntactor is the primary teller. Discrete and continuous infinities are one because they are the union of opposites. So Aleph Null is an there's an operation that maps between Aleph Null and 2 to the Aleph zero null, and this is a conditional equality. It's not the same as an equal sign. That's why there's a little marking in the top left corner. But it's an operator. So that means that there's a mapping that acts on elements of a space to produce an element of another space. So these two spaces produce one another, both the continuous and discrete number lines, discrete and continuous infinities. It's the yin and yang of their relationship to one another, infinite wholeness and infinite singularity. infinities, 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 infinities in infinities in infinities. The whole world is full of his infinite glory. God bless. Limits are incredibly important to mathematics, especially for differential and integral calculus. An infinitary limit is not a quantitative notion of approaching nearer and nearer to a quantity, but it is an ordinal construction. An ordinal number is first, second, third, 11th, whereas a cardinal number is 1, 2, 3, 11, and so forth. So the cardinal, the ordinal would be like the 10 millionth or something, but it's actually the infinitieth term in the series, which is continually defined through this non-terminal process, which is iterating through from one ordinal to the next in the n+1 series, as we've discussed numerous times before. Russell says, although the numerical difference between Aleph null and a finite cardinal is consistent and infinite, from a quantitative point of view, finite numbers get no nearer to as they grow larger. What makes the limit of the finite numbers is the fact that in the series, it comes immediately after them, which is an ordinal fact, not a quantitative fact. And that's an important distinction. This means that the limit is defined as the closest you can get towards Aleph null, namely approaching it through successively higher ordinals, 10 millionth, 10 millionth and 1, and so forth, in a set. Therefore, limits can be reformulated the same way in which we define infinity, as a non-terminal operation. Something being subjected to infinity, unbound increase, approaches the limit which is operating on it. Thus, infinity serves as both the pre-programmed object, the limit, and the process by which it eventually reaches its destination over an unbound interval. Therefore, we can define the upper limit as a boundary of a process, the progression of set Aleph, or the progression of set alpha, which is not a member of set alpha itself. Thus, the non-terminal limit can be thought of as an extrinsic boundary to alpha, whereas the maximum of alpha is a boundary which is a member of set alpha. The limit is not the same as the maximum. The maximum is a self-contained boundary. The limit is rather an unbound process. Referring to the greatest infinity, the famous set of all sets, Bertrand Russell writes, the comprehensive class we are considering, which is to embrace everything, must embrace itself as one of its members. In other words, if there is such a thing as everything, then everything is something and is a member of the class everything. But normally, class is not a member of itself. Mankind, for example, is not a man. Form now the assemblages of all classes which are not members of themselves. This is a class. Is it a member of itself, or is it not? If it is one of those classes which are not members of itself, i.e., not a member of itself. If it is not one of those classes that are not members of themselves, i.e., it is a member of itself. Thus, of the two hypotheses, that is, that it is and that it is not a member of itself, each implies it's contradictory. This is a contradiction. The paradox can be expressed like this. A male barber shaves every man in town who does not shave himself. Does the barber shave himself? The answer at first seems obvious. Of course the barber shaves himself. He's not shaved by anyone else, right? Wait, but if he shaves himself, then he doesn't need to be shaved by the barber, right? But he is the barber. Whoops. So this is called Russell's paradox in set theory. This thought experiment is a popularization of this idea of self-inclusion of sets, which asks a question about a set of all sets that do not include themselves as elements. If this set includes itself as an element, then it is self-inclusive and therefore not part of its set. But if it does include itself as an element, then the set must have a self-inclusive set as an element. Do you see the problem here? The CTMU solves this paradox. Langen says, by noting that reality uses self-inclusion all the time. Nature does not have to obey type theory, Russell's stratification and solution to this problem, which excludes self-inclusion from logical argument. It laughs at type theory. So Langen's saying nature is like, ha ha, look at you, Bertrand Russell, what a bum. We don't care about type theory. It's like that got him. But yeah, so basically you've got to have something that resolves the paradox on another level entirely. And of course, the CTMU does that by using the concept of self-duality or dual inclusion. You've got to, on the one hand, have topological conclusion in which a space or point set contains smaller and smaller and smaller and smaller sets. Then you've got linguistic or descriptive inclusion in which an expression contains all of that which is implied. These two forms of inclusions work in a self-dual way. A set topologically contains its elements, but meanwhile you can say that each element descriptively includes the sets. He continues, you can do that simply by imputing a certain syntax to the element, which is an operator, which is an identification operator. This is how reality is built in the CTMU. It is built out of identification operators, so Russell's paradox cannot arise in any form that is not immediately resolved by the CTMU self-resolving paradox. Therefore, the idea of a self-contained infinity or set of all sets is made extensive use of in the CTMU as the conceptual model for basic ideas, such as the reality principle, which says that reality contains all and only that which is real, the MAP, the universe is self-creating, self-explaining, and self-sustaining, super tautology, and systemic self-duality. This means, in contrast to the linguistic paradox, which is irresolvable, all that you must do in order to solve the self-inclusion paradox is, in set theory, is ask whether the set topologically contains itself or descriptively contains itself. We were using the same term previously for two analytically separate phenomena, and that's why we had paradoxes like this, but the CTMU fixes that problem. So that means that whether its elements are contained within it or if it contains its own elements, at every moment of reconstantion, the focus shifts from inner expansion and non-terminal domain N, representing the elements consisting or containing the ontic potential of the system, to requantization in terminal domain T, in which the systems recontain the actualized elements. So thus, the paradox gives rise to the CTMU's model of dual self-containment, which lays the conceptual framework for advanced ideas like syntax-state duality, telic recursion, and the concept of a self-actualizing in T, self-potentializing in N, reality self-simulation that works to resolve the self-inclusion paradox through evolution. The reason why the system evolves is basically because it has to get a hold of itself and requantize according to a cosmic self-selection parameter called generalized utility. The idea of the infinite and the limit bear heavily on the CTMU, which is, after all, a mathematical metaphysic, the most general human cognitive discipline that uses mathematics as its logical structure, injecting it with metamathematical structure and thereby bringing it into alignment with its proper referent context, the real SCSBL universe. In metamathematics, theorists become modelers, in effect bringing the mathematician into the equation and injecting human cognitive perceptual syntax, HCSPS, into the structure and foundations of mathematics. Obviously, the foundations of mathematics are not elementary relations or even axioms, but the cognitive structure through which these relations and axioms can be expressed. Logical structure is the product of the human mind, in particular the logico-mathematical subsyntax, or LMS, which characterizes human abstraction and reasoning about the character of existence. Therefore, mathematics is the obvious structure on which to base our study of existence because, properly conceived, it models the relationship between the theorist and the abstract mathematical structure. Where logic is mathematical, it also denotes the structure of truth. Illogical statements are untrue, after all. So too is the CTMU, which is a metaphysical formulation of logic with a special kind of algebraic system called SESPL, the self-configuring self-processing language, which is the language of the infinite. Therefore, reality expresses itself in the language of the CTMU. CTMU mathematical metaphysics, which is the ultimate termination and culmination of all of our theorization. So thank you. God bless. Take care. In the next topic, we'll be covering a ton of topics in CTMU metamathematics. I can't wait to see you all there. Chapter 9, our final one. Thank you. Let the light shine forth in the darkness. May the peace of our Father in heaven be upon you. Like and subscribe. Peace.